Now where this, to make it practical here, let's say this is your car window, and it's a cold morning, and you go get in your car, and it's clear. When you first get in the car, the window's clear, right? And say it's a small car, and you've got some people in there, and you turn on the heater. What's going to happen in very short order is you're going to get, your windows are going to get, we call it frosted, but that's a problem. It's going to get, let's say frosted for now. Why? What's happening there? Why is it doing that? And you think about it, this is real cold. It's real cold outside, and you warm it up inside here. Fine, I'll use red. So it's warmed up. You warmed it up in here. This little pocket of air right in here, right against the window, is going to be colder, and you're going to reach the dew point of that air. Right? Out here, it's warm, and so you're fine. But right at that little spot, little layer of air along the window, you've reached the dew point, and at that point, the air cannot have any more water in it. Water is going to start condensing out of the vapor. Where's it going to go? It's going to go right on the window, right? And your window is going to get fogged up, if you wish, right? Because the air closest to the window cannot have as much moisture in it as this air. So it's got to go somewhere, so it comes out on your window, right? Now, what do you do about that? Now, here's the real misnomer of this whole thing, is you turn on your defroster. But here's the problem. This is not frost on your window. It's dew. So I'm hereby making a motion that we should rename our defrosters and call them de-dewers. Okay, so will you join me in that effort? We got to call it a de-dewer. It's not a defroster. That's not frost on your window. It's dew. Okay, so it's a de-dewer. Turn on the de-dewer, dear. Yeah. So what you do is you turn on your defroster and blast this, your de-dewer, sorry, with warm air. What you're doing is you're warming up the car window. Right? You're making the car window warmer. Right? And now there is no layer of air that has a lower dew point, or that has a lower temperature, so it doesn't have a lower dew point. Now outside the window is still cold, but that's probably, that air outside the car is pretty low moisture if it's a cold morning. One of the things, you might have some people in here that are breathing, and you're putting out moisture in the air. But the thing is, now that you've warmed this up, now there's no more, the air is no longer at its dew point, so it doesn't go anywhere. Okay. Now, we used to have, when I was a kid, a Volkswagen. One of the original Volkswagens had a split back window. It was very cool. It didn't have a defroster. All right. So now we've got a problem. What do? You kind of keep wiping it? Well, really what you could do is just turn off the heater and keep all your windows open, right? Keep all your windows open. And then the air inside the car is the same as the temperature outside the car. And then you won't get any dew forming on your window. Right? So that's a possible solution to that. Now, I grew up in New York. Not a good place to go driving around in the morning in the winter with your windows open, but that would do it. Okay. Either way, you either have to warm up the window so there's no dew point in the car, or keep the temperature in the car the same as the temperature outside the car. Okay, that would take care of that problem. I don't know what numbers that covers on here. This question about why you can see your breath sometimes in the morning when you're breathing, and you can see the breath from the air. It's the same idea. That air that you're breathing out of your mouth is warm and moist. And the air out here is cold. So this air very rapidly cools down. It reaches the dew point, and it has to go somewhere. So what it does is it doesn't settle out in drops where it falls to the ground. It forms basically a cloud. That's what fog is. As you're breathing it out, it can't hold that moisture anymore. It's got to go somewhere. And so it just forms a little cloud. You can see that on windows too. If you blow on windows, you'll see that. Well, many questions that come up with humidity and things. And one of the classic ones is, why does a 90-degree day in Florida feel so much hotter than a 90-degree day in Arizona? Right? I don't know if you've ever been to Florida or any really humid place. 90 degrees in Florida would be horrible, and can be horrible because the humidity is much higher. I'm actually torturing myself talking about a 90-degree day in Arizona. If you can see the snow out the window there. A 90-degree day in Arizona sounds really nice right now, but ain't gonna happen. The difference is the humidity in Florida is so much greater, but why does that make it feel so much hotter? All right. In order to answer that, you got to understand this point of what sweat is. If you remember in 7th grade science, we talked about sweat in the integumentary system, and there's always that question, how does sweat cool you down? And still, even the last final on the last day, after I don't know how many times, some of you were still saying, sweat cools you down because it's cool. Well, it's not cool. It's at the same temperature as your body. Right? It's not cooler. Right? And then some of you would say it cools you down because it's water. What does that mean? Just because it's water, why does that cool you down? Right? And you got to understand, when you sweat, the reason sweat cools you down, it's not that there's water on your skin, it's that the water evaporates off your skin. Right? Now, that process of evaporation takes heat from the surface of your skin. It has to do with the kinetic energy of the molecules that the ones that leave the liquid phase on your skin have more energy, leaving lower energy ones left, and so that's basically cooling you down. So the reason sweat cools you down is when it evaporates, it cools you down. We have this thing called wind chill, right? Where if you have a cold day and it's real windy, wind chill temperature is much lower than that, and it can be rather dangerous if it's a bad wind chill. Why is that? Well, because what it's doing is the wind is taking moisture off your skin, and so it feels colder. Kind of the opposite form of it. So the idea is, in order to cool you down, you sweat. So when you're in Arizona, you're sweating like a pig, maybe, but that sweat is evaporating. It comes out and evaporating, and that's cooling you down. So the sweat is doing, I'm going to fix my hair here. The sweat is cooling you down. When you're in Florida, and the humidity is, say, 85 or 90%, that sweat doesn't evaporate. Right? And if you, like in that little picture we had, you're going to reach a point where no more liquid off your skin can evaporate. It has nowhere to go. Right? You're near the saturation point. So that sweat on your skin doesn't evaporate. So you don't get the cooling effect of sweat. And it can actually be very dangerous. If you were at 100% humidity, that sweat is actually going to make it worse. Right? Sometimes they say, you shouldn't wipe the sweat off your face. Well, if you're in Florida, you need to do that. Right? You've got to get that off there. It's almost like an insulating layer. So that's why it feels so much hotter in Florida and in Arizona, even if they're the same temperature. Right? Another question that is kind of interesting is, why does it feel so cold when you get out of the shower? Right? Now, I'll put a picture up of a guy from a physics book so you don't think of me in the shower. But picture that you're in the shower and it's nice and warm, and then you forgot your towel, and so you have to run out and get it, and it's really cold out in the bathroom while you go get your towel. Right? Why is that? And you say, well, because it's colder in your bathroom than it is in the shower. And actually, that's not right, really. I mean, it really is not any warmer or colder. It's pretty much the same temperature. Now, if your shower, sometimes in the old days, they used to build showers that were completely enclosed all the way up to the ceiling. Okay, that air might be a little warmer. But if you have one of those showers nowadays where it's open at the top, the temperature inside the shower stall is pretty much the same as the temperature in the bathroom. It's not any warmer or cooler. So what we have, it's kind of the opposite of the Florida-Arizona question. All right? Inside the shower, it's nearly 100% humidity. So you have water on your skin, but it's not evaporating. Right? So you're not cooling. It's not cooling you down. Right? As soon as you step out of the shower, though, and I mean like right away, that water starts evaporating. And now that it's evaporating, it starts to cool you down. And you feel cool, and it's that fast. It really does work that fast. So that's why if you were to completely dry off, if say you didn't forget your towel, then it doesn't feel that much colder because that water is not evaporating off of the shower. Okay, so that's another